So hello all, welcome to tutorial session 3. Today we will discuss about the week 3 lecture, some brief recap and the problems related to joint displacement in truss structure. So before moving to today's class, are you facing any problem from past two classes? If anyone, please unmute and say if you are facing, or do you want some feedback? Okay. So today we will discuss about virtual work method. So come to this figure B first. Now these loads, this is a rigid body. Suppose A, this is a rigid body where P1, P2 and P3 are the external loads that is acting on this body A. When those loads will be acting, the body will try to deform. Let the deformation is occurring like this, which is shown by this dotted line. Let us consider a point A. This is A point. Here, the displacement is delta. And we need to find this displacement delta, which is real displacement occurring due to these real loads P1, P2, P3, which are external in nature. Due to all those external loads, there are some fibers or some elements inside this rigid body. This might be one element, this might be one element. Due to this load, there might be elongation, compression, or bending of this element. So let this element, which was initially of length L, extend to delta L. So delta L is the elongation. And elongation, this is internally occurring on these rigid body elements, internal rigid members due to external loads. Now, this is part 1, suppose. We need to determine this delta. So let us apply in this point A virtual force. Which virtual force means that force is originally not acting in this rigid body A, but we are assuming a unit load that will act on the point where we are interested to calculate the displacement, that is delta. So as we know, work is equal to F dot dr, and it can be integrated over the line. So now the displacement is happening in this direction. So we have assumed that the unit load is also acting in the same direction, such that F dot dr, which you can write like F into dr into cos theta, and here theta you are making to be 0 degree, so it is becoming F dr. The work is becoming F dr. Now this is virtual load, so the work done here will be external virtual work. That will be equal to 1 into this delta. Now, when these external loads are acting, a delta L displacement is occurring in the external element, internal elements also. And for this 1 unit virtual load in that element, let U be the force that is getting generated in this internal element. So the internal virtual work done will be U dot delta L. Since we are considering for a single element and there will be n number of elements present within this rigid body. So if we will integrate this, then we will get the total work done which was carried out internally due to the virtual load, external virtual load 1 that we have applied to calculate this external displacement, which is real in nature, that is delta. So now we know external virtual work done will be equal to internal virtual work done. So from here, what we can write? 1 into delta equal to integration U dot delta L. So from here, we will get delta equal to U dot delta L integration. So coming to the procedure for truss, how to determine the joint deflection in truss using the concept of virtual work. First here I will tell all those procedure. Next we will go to the figures and know how it is determined. So first step is we need to identify all those member forces in a given truss. So in the previous class we studied method of sections and method of joints to determine the member forces. So these two methods we can apply to calculate the member forces in each member of the truss. That will be our first step. The second step will be to calculate the force in each member due to unit virtual load. That means, see this figure. Like this is our original truss structure where W1 and W2 are the external load. So by method of section or by method of joints, we can first determine the force in all those members. After we are done with all those member forces, which we generally called as P force system, we need to determine this delta. So as stated, if you want to determine this delta, this is vertical deflection, then remove all those external loads and apply at that point a unit virtual load in the same direction in which you want to find the deflection. So we applied this 1 unit load. Then again the similar procedure for this 1 unit load, you determine all the member forces. After you are done, this is called as K force system. So now read this statement. Calculate force in each member due to unit virtual load applied in the direction of displacement that needs to be calculated. That is K. This K force system. Now arrange all those calculated values in a tabular format as given below. I will show you the table, how to store it and how to calculate it. We will see in subsequent slides. Now, here, the same thing, this is virtual load. So 1 into corresponding displacement, which is real displacement, that is delta. This is the external virtual work done, and that should be equal to U dot delta L. You can also write this U as K here. This K force system or U force system, there is no fixed notation, but you can use either of those. So K into delta L. Now for truss member, we know those are axial members. So if this P load is acting, so we know, if you want to find what is the elongation delta L, it will be PL by AE. That we know from basic solid mechanics knowledge. So when you substitute here, it will be K dot PL by AE. And that is for one member. And when you do summation for I equal to 1 to M, where M is the number of members, you will get 1 into delta equal to summation K dot PL by AE. So from here, it will be delta equal to K PL by AE whole summation for all those members. So up to here, is it clear?
Yes, sir.
Okay. Now, this is the table I was talking of in that procedure. So here the members, like suppose you have a truss like this, and here hinge is there, and one roller is there, and let this 10 kilonewton is the external load here, and 5 kilonewton is the external load. So by equations of static equilibrium, we can calculate the reaction forces. First task is to calculate the reaction forces. After that, you need to calculate all those member forces that we denote it by P force system. So let this joint be A, this joint be B, this joint be C, and this joint be D. So the members are like this. We have member AB, we have member BC, we have member AD, we have member BD, and we have member CD. And this P will be the member force due to all those external loads present. So this is nothing but the P force system. Now, coming to this step, that is the third step. K force system or U force system. Suppose we need to calculate the vertical displacement of joint C. So we have to redraw and now we know all those reaction forces. Let this be dy, ay, and ax. Remove all those external loads and place a unit virtual load in the direction in which you want to calculate the displacement. Like I said, we need to calculate displacement of joint C in the vertical direction. So I have assumed a unit vertical load in the joint C in downward direction, and I need to calculate this displacement. So for this 1 unit virtual load, you calculate all those member forces again without considering, note, without considering the external forces. For this virtual load only, you need to calculate the member forces. That will denote this K force system. Now, L represents the length of all those members. That is, suppose this is 2 meter, 3 meter, 4 meter. Let this also be 2 meter, 2 meter. So AB will be, here you can write 2 meter, BC will be 3 meter, AD will be 2 meter, BD will be 2 meter, and CD will be 4 meter. And AE represents axial rigidity. Here, where A is the area of the member, that is cross-sectional area, and E is the elastic modulus or modulus of elasticity. So now you know the K for each member, you know the L, you know AE for each member. So this PL by AE is coming from here. This PL by AE, that is real internal displacement occurring due to the external loads. So K into PL by AE for each member you can note down now. Now when you will do the summation of K into PL by AE will give you the required displacement for the joint C, what we are interested in. But if apart from only external loads, there might be at some times there might be variation in temperature for a given member, or there might be a member might have been shortened or lengthened, that we call lack of fit, due to which some reaction forces will arise. So for that also you need to calculate the K again multiplied by this alpha delta T. Alpha L delta T means alpha is the temperature coefficient, L is the length, and delta T is the temperature change. So this is giving us change in length. And delta, that is lack of fit, that will directly be given in the question. So when you will add up this K into alpha L delta T and this summation of K into delta, what is written here, you will get the total displacement for this, suppose for this joint C, due to external loads, due to temperature variation, and due to lack of fit. So combinedly, when you add up, you will get the total displacement for the given joint which you want to calculate. So now let us solve some problems. Now, see, here in this question, they are asking, we need to determine the member forces AB, BD, and DC. Where is AB? AB is this member, BD is this member, and DC is this member. And for each member, the cross-sectional area they have given that A is 400 mm square, and E is 200 GPa. GPa means 10 power 9 Newton per meter square. So from here we can directly calculate AE, that is axial rigidity, will be 400 mm square into 200 into 10 power 9 by 10 power 6. That becomes Newton per mm square. So from here, this will be 400 into 200 into 10 power 3 Newton. So let us convert it into kilonewton. So 400 into 200 into 10 power 3 into 10 power minus 3, this will be kilonewton. So 400 into 200 will be 80,000. 80,000 kilonewton. Now we need to determine the reactions. This is roller support. So when we will draw the free body diagram, one vertical reaction will come. This is AY. And here, this is hinge. So EX and EY. So now we can write the equations of static equilibrium. Summation of Fx will be equal to 0. When we'll write this, we'll get Ex equal to 0. Let this be equation. Now, when we'll do summation of vertical forces equal to 0 along this direction to be positive, we'll get AY plus EY minus 15 into 2 equal to 0. This implies AY plus EY equal to 30. Let this be equation 2. Now, we can do summation of movement about point E equal to 0, and in clockwise fashion, we will consider it as positive. So AY, the lever arm is 8 meter, minus 15, the lever arm is 4 meter, and for this 15, the lever arm is 0, so this 15 won't be considered, and that will be equal to 0. So AY equal to 60 by 8. So AY is coming to be 7.5 kilonewton. Let this be equation 3. Now, when you will substitute equation 3 in equation 2, we will get EY equal to 30 minus AY, and from AY we have AY value was 7.5, this will be 22.5 kilonewton. So now we are done with all those reaction forces. Now we need to determine this member force. So it's simple. Let us draw the free body diagram for joint A. So here for joint A, we have this AY is 7.5 kilonewton. This is FAB. And this is FAD. And this is 3 meter. Let this angle be theta. So from here, this will be 5 meter. this will be 5 meter. So this angle is theta. So we can write summation of Fy equal to 0. So from here we will get, and this vertically upward is positive. So FAD sin theta plus 7.5 equal to 0. This implies FAD will be equal to minus 7.5 by sin theta. So what is coming? Can anyone tell what is the value of FAD? It is coming out to be minus 12.5. Sorry, not FAD, yeah. FAD is minus 12.5 kilonewton. Now we can write for the same joint summation of Fx equal to 0. And this direction we are considering to be positive. So what we can write, FAB plus FAD cos theta. FAB, this is FAB in the horizontal direction, and FAD cosine theta will be in the horizontal direction. So FAB plus FAD cos theta will be equal to 0. So from here, FAB will be equal to minus FAD cos theta. So already we know FAD is minus 12.5. So minus of minus 12.5 will be 12.5. And here cos theta will be 4 by 5. So what we are getting will be AB, right? AB is 10 kilonewton. After simplifying, we are getting FAB as 10 kilonewton. Now we got our first member force, that is FAB. Now when you will come to this joint B, you can directly see when you will draw for joint B, here FAB will act like this, FBC will act like this, and FBD will act like this. And when we are doing summation of force along y equal to 0, you will directly get FBD is a 0 force moment. So this is a 0 force moment. So we are done with AB and BD. Now we need this member DC. Now when you will do summation of Fx here for this joint B, you will get FBC equal to FAB. So from summation of Fx equal to 0 at joint B, we will get FAB equal to FBC. FAB equal to FBC equal to 10 kilonewton. So we got this member force also. Now we can go to this joint C. Let us draw the FBD for joint C. FBC will act like this. This is 10 kilonewton. Here 15 kilonewton load is there. Here one member force will come, that is FCE. and one inclined member is also there, which is FCD or FDC. And this angle will also be theta, because this 3, 4, 5 is a right angle triangle, and these 3, 4 and this will also make 5 meter, will also be the similar right angle triangle. So let this be theta. Now we can do summation of force along x equal to 0. From here, what we will get? F, let this direction is kept as positive. So minus FDC cos theta minus 10 equal to 0. This implies FDC cos theta equal to minus 10. From here, FDC will be equal to minus 10 upon, what will it be the cos theta value? It will be base by hypotenuse. So 4 by 5. So 4 upon 5. So minus 10 into 1.25. So minus 12.5 kilometer. This minus represents compressive force. Now we got our desired member forces. That is FAB we got as, here we got FAB 10 kilonewton tension, FBD is 0 force member, and FDC is minus 12.5 kilonewton compression. So A option is the correct one. Now, for this question only, we need to calculate the displacement at, let us see, displacement at joint B. That is vertical displacement here we need to calculate. So for that, we need to calculate for those external forces, what are the member forces? And after that, we have to remove these external forces and we have to apply one unit load at joint B vertically. And for that, we need to calculate those K force system for this virtual unit load at joint B. After we are done with that, we can tabulate it in this table, and we will calculate the summation of K dot PL by AE, which will ultimately provide us the deflection of point B in the vertical direction. That is our question. So before that, we need to calculate all those member forces. So we have calculated FAD here. FAB is also done. FBD is a 0 force member. FBC is done. FCD is also done. So now we are only left with these two, FED, member force in member ED, and EC. So we can draw the FBD for joint E and calculate those two remaining member forces. So joint E is like this, and here we have EX, which is 0, FED is the member force, FCE is another member connected. The member force will be FCE, and EY. EY is upward. And what is the value of EY? This is here 22.5 kilonewton. So 22.5 kilonewton. Now we can directly do summation of Fx equal to 0 again. We will get directly FED equal to 0. Means This is also a zero force member. Now, similarly, when we will do summation of Fy equal to 0, we will get Fec equal to 22.5 kilonewton. So now we are done with our P force system. Due to external loads acting on the given truss. Now the next question is asking about, for that same question, that is question 1, we need to calculate that vertical displacement. So before that, we need to put that unit load at joint B. So the statement is written, place a unit load in the downward direction at joint B and calculate all the member force in AB, BD and DC. So let us redraw the truss and put that unit load at joint B. So here it was roller, so one reaction. Here it was hinge, so two reactions. This joint was A, this joint was E, this joint is C. We have another member here. This is B, and I guess this is D. So here we need to put one virtual load of unit concentration here to calculate the displacement. So this will give us our desired K force system. So now similarly we have to do C. Here this is EX, this is EY, this is AY, and this unit load is acting at joint P in the vertically downward direction. So now what can we do? We can directly write summation of Fx will be equal to 0. From here we will get Ex equal to 0. So this force is 0. Now as when we will write summation of Fy equal to 0, we will get Ay plus Ey equal to 1. And we are considering upward to be positive and right side to be positive. So this is equation 1, this is equation 2. Now let us do summation of movement about point E of I equal to 0. When we will do it, and here I am taking clockwise sense to be positive. So Ay into lever arm, this was 4 meter, this was 4 meter, and this vertical length was 3 meter. So Ay into 8 meter clockwise minus 1 into 4 meter. This is 4 meter, so lever arm will be 4 meter about E, and that will be equal to 0. So we are getting Ay equal to 1 into 4 by 8. So 0.5 is the value of AY, sorry. So we got AY to be 0.5. So putting AY here in equation 2, we will get EY equal to 0.5, same value. So we got EY to be 0.5. Then again, we need to do the same thing. Let us take again this joint A, draw the free body diagram. AY we know as 0.5. This is KAB and this will be KAD and this angle let it be theta. So now summation of Fy equal to 0 if we will do, it will give us KAD and upward is positive as usual. KAD sin theta plus 0.5 equal to 0. This implies KAD will be equal to minus 0.5 by sin theta, and sin theta is if this is theta, sin theta will be 3 by 5 and cos theta will be 4 by 5. So 3 by 5. So we are getting minus 0.5 into 5 by 3. So what is the value? Minus 2.5 by 3 is KAD value. Now we can do summation of fx equal to 0. Then we will get KAD cos theta plus KAB equal to 0. This implies KAB will be equal to minus KAD. Minus KAD is 2.5 by 3 into cos theta will be 4 by 5. So 1 by 2, 2 by 3. So KAB we got and KAD we got. Now when we will take this joint B, let us take here. Joint B. For joint B, it is easy because one unit load is there and this KAB and this side KAC and upward it will be KBD. So now here if we will do summation of fx equal to 0, we will directly get KAB equal to KAC equal to, what is the value of KAB? This is 2 by 3. So equal to 2 by 3 units. Similarly, KBD will be equal to 1 unit. So we got this K force system for this member, K force system for this member. Now we can directly go to joint E. If we will see for joint E, here this is 0, so I am not considering this now. This will be KCE, this will be KED, and this top force is 0.5 units. So from here you will get KED equal to 0 and summation of Fy equal to 0 if we will do, we will get KCE equal to 0.5. So we got KCE, we got KED, we got 1, 2, 3, 4. The remaining this CD member force needs to be determined. So let us draw for joint C the free body diagram. This is joint C, and in C, three member force will come out. This will be K CB, this will be K CD, and this will be K CE, I guess. Yeah. Now this angle is same theta. So now we can write summation of f x equal to 0, this direction to be positive. So minus k cd cos theta minus k cb equal to 0. This implies k cd cos theta will be equal to minus k cb. This implies kcb. Now the unknown is kcd, so it will be minus kcb by cos theta, and cos theta is 4 by 5. So minus kcb. What is the value of kcb? cb. Huh. cb. Sorry, this is CCB. So this is BC or CB. So KBC. So it is 2 by 3. So minus 2 by 3 by 4 by 5. So it will be minus 2 by 3 into 5 by 4. So minus 10 by 4 3 is 12. So minus 5 by 6. So now we got all the member forces due to this 1 unit virtual load. So now we can fill this table. Let us fill this table. I have already done it. I am writing it directly here. Before doing that, we have to see the options here. Now for this 1 unit load, we need to calculate the member forces in AB. So in AB, we got 2 by 3, and that is positive, means tensile. So FAB equal to 2 by 3 tension. And FBD we got 1. And 1 is positive, means that is also tensile. So FBD is 1. And FDC, where we got FDC. FDC at the last, that is minus 5 by 6, and minus represent compressive. So minus 5 by 6 also can be written as minus 2.5 by 3. So 2.5 by 3 and minus represents compression. So option C. Now let us fill this table. I have the data, I am filling it directly so that we will save some time. Member AB, AD, BD, ED, CD, CB, CE. You just cross verify and let me know if there is any mistake. AB is 10 minus 12.5, 0, 0, minus 12.5, 10, 22. And that K4 system means due to that unit load at joint B, vertically down. So for that we got 2 by 3 minus 5 by 6, 1, 0, minus 5 by 6, 2 by 3, and 1 by 2. And the lengths for AB, it is 4 meter, BC, it is 4 meter. So for AB, it is 4 meter, AD, it is 5 meter, BD is 3 meter, ED is 4 meter, 5, 4, 3. CD is 5, CB is 4, CE is 3 meter. CE is 3 meter. Now, A is the cross-sectional area which is constant for this problem, that is 400 mm square, and E is modulus of elasticity, that is also constant for each member, that is 200 into 10 power 9 Newton per meter square. So when you will do it as I have done previously here, we got AE as 80,000 kilonewton. So for every member, it will be 80,000 kilonewton. There might be some problems where A and E will be varying. For that case, each member will have different axial rigidity. So we have to take care and we have to calculate it for each member where A and E both are varying or one of the component is varying. So now just multiply this K and PL by AE. So we will get, let us do it like this. KPL, for this it is coming as 80 by 3 AE. I am not substituting AE value because after substitution it will be very small. So after we are done for every other part, we will substitute the value of AE there. 3 AE. This will be 0. Now see, P is 0 means 0 multiplied by anything will give us 0. Here 0 and K is also 0. So 0 multiplied by anything will give us 0. And this will be 156.25 upon 3 AE. This will be 80 upon 3 AE. And this will be 33.75 upon AE. So when we will do, we know our delta will be equal to summation of K into PL by AE. So from here, if we add up, we will get summation of KPL is 191.2 by AE. So now, if we will substitute the value of AE as 80,000 kilonewton, this is 25. We will get 0.00239 meter, which can be approximated to 2.39 mm. Now, since there was no change in temperature for any member, so delta T was 0. So for every case, it will come out to be 0. So no need of this part. And there was no lack of fit. So this portion will also be 0 for this case. So our option is 2.4 mm. So till this point, anyone having any doubt?
No, sir.
Okay. Now we need to solve this problem. The methodology is same for each and every problem. It might be cumbersome, tiring, but the methodology is same. So here, this is a comparatively easy problem because only 3 members are there, so we can easily do it. So let us do it. We need to determine the vertical displacement of joint B. Vertical displacement of joint B means this joint, how much it is moving in this direction. So first, step 1, calculate the reaction forces. Or supports reaction. Now this is a roller, so one reaction will come AX. This is a hinge, so two reaction will come, one along x-axis, that is CX, one along Y, that will be CY. So now we can use the equations of static equilibrium. Now summation of Fx equal to 0 if we will do. So it will be Cx plus Ax equal to 0. So let it be equation 1. When we are doing summation of Fy equal to 0, we will get Cy minus 80, and along this direction I am taking it to be positive, and along upward direction I am taking this to be positive, equal to 0. So from here we can get Cy equal to 80 kilo. Let this be equation 2. Now we can do summation of movement about point A equal to 0, and let the clockwise fashion be positive in nature. So now Cx into the lever arm will be this total length, this is 6 meter, plus 80 into the lever arm will be this 4 meter, will be equal to 0. From here we will get Cx equal to minus 80 into 4 by 6. So what we are getting, minus 160 by 3 kilonewton. Now we are done with, after we are done with Cx, let this be equation 3. We can substitute this Cx value in this equation 1 to get Ax value. So after substitution, we are getting Ax to be equal to minus Cx, which will be equal to minus of minus 160 by 3. That will be equal to 160 by 3 kilonewton. So with this, we calculated all those reaction forces. Now, the step 2 will be to determine the member forces, that is our P force system. So for this, we can start from this joint A. Let us take joint A. Draw the free body diagram. Here we got Ax as 160 by 3. There won't be any reaction this side, and two member force will come. This as FAB, this will be FAC, and this will be FAB. Now Let this angle be theta. Now we can write cos theta will be equal to, this is 3, this is 5. So 3 by 5, and sin theta will be equal to 4 by 5. Now we can write summation of force along x equal to 0. This will give us FAB into sin theta. Sin theta is 4 by 5. So 4 by 5, and this direction I am taking to be positive. FAB sin theta plus 160 by 3 will be equal to 0. This implies FAB will be minus 160 by 3 into 5 by 4. So what we are getting? FAB. We are getting FAB as minus 200 by 3. So FAB we got as minus 200 by 3 kilometer. Similarly, when we will do summation of force along y equal to 0, we will get the equation as, and this upward direction will be positive, FAC plus FAB cos theta will be equal to 0. This implies FAC plus FAB is minus 200 by 3. So minus 200 by 3 we are substituting, and cos theta is here 3 by 5. So substitute 3 by 5 in place of cos theta, and that should be equal to 0. So FAC we are getting 40. Let me check. Yeah, this is 40 kilonewton. So now we are done with the member force for member AC and AB. Now we can calculate the member force FBC. So let us do it here only. For joint C, the free body diagram will be something like this. Cx is negative minus 160 by 3. Means this side is showing us negative value. So when we reverse that direction, it will be positive. So 160 by 3 this side. Cy is 80 upward. And this member force FAC we already calculated, that is 40. And this FBC is the only unknown, and this angle is theta. So let us do directly summation of Fx equal to 0, as we have only one unknown. So one equation is more than sufficient to calculate that. So FBC sin theta, and this direction I am taking to be positive. FBC sin theta minus 160 by 3 equal to 0. So upon simplifying this, we will get FBC equal to 160 by 3 sin theta. And when we substitute the value of sin theta, it will be 5 by 4. So what we are getting? BC value is coming out to be 200 by 3 kilonewton. So we are done with our P force system. So let us write member AC, AB and CB. Our P force system, for AC it is 40, for AB it is minus 200 by 3, and for BC it is 200 by 3. Now we need to determine this K force system. due to unit load at joint B. So it will be something like this. We need to calculate the vertical displacement. So vertical unit load at joint B, this is joint C, this is joint A. In joint A, there is roller support. So this will be AX. At C, the support condition is a hinge support condition. So two reaction CX and CY. What else? That's it. This is the free body diagram. Now see, directly after seeing the figure, you can see when we will do summation of Fy equal to 0, this one is acting downward. So Cy is acting upward. So the magnitude of Cy, you can directly write it as 1. Now see, this Cy equal to 1 is acting upward, and B at joint B, this unit load is acting downward. So they are trying to make a couple. And when a couple will come, the member or the complete structure won't be there in the state of static equilibrium. It will try to rotate it. So who will try to safeguard it and keep it in the state of static equilibrium? This Cx and Ax force. So this you can see like this. Just I am doing it here. This Cy of 1 is acting here, and this external unit load is acting here, and the distance between them is this length. This is 4 meter. So this is 4 meter. So they are making a clockwise couple. So this Cx and Ax, the values will be such that this clockwise couple will be neutralized and the complete structure will be in the state of static equilibrium. So if this clockwise couple can be done with the help of this Cx and Ax in the form of an anti-clockwise couple, then of equal magnitude. Obviously, the magnitude should be same such that the clockwise rotation and the anti-clockwise rotation will neutralize itself and it will become 0. That means the complete structure will be in the state of static equilibrium. So now see, here we have shown Ax in this direction and Cx is also in this direction. But when we will do summation of Fx equal to 0, this will give us Cx plus Ax equal to 0. That means Cx and Ax, the magnitude wise they are same, but the directions are different. Now we have to make this to a anti-clockwise couple. So anti-clockwise couple can be made when you show Cx in this manner and Ax in this manner. Means our assumption of Ax in this direction is correct and assumption of Cx in this direction is wrong. So if we will do by taking that summation of Fx equal to 0 and summation of movement about A equal to 0, we'll get Cx value to be negative, as we have assumed this direction to be positive. So here 1 into 4 meter, this is the clockwise movement. This should be neutralized by Cx and Cx. Both are magnitude wise, both are now same. So Cx into what is the lever arm here? This is 3 plus 3, 6 meter. So 6 meter. So from here you can get Cx equal to 4 by 6. That is 2 by 3. So Cx this side is 2 by 3 and Cx here, which is equal to Ax, will be equal to 2 by 3, but the directions are different now. Magnitude wise it is same, but directions are different. So now what we can write? Here we got what we got. AC will be half, AB will be, wait, we have done something wrong or what? Let me add one slide. So this is 1 unit load. This is AX. This is CX. This is CY. And this distance is 4 meter. This is 3 meter. This is 3 meter. This is joint A. This is joint B. This is joint. This is joint B. And this is joint C. So by conventional method, we should check once. So summation of fx equal to 0 when we are doing, this will be cx plus ax equal to 0. That is equation 1. And cy equal to 1 from summation of fy directly we can get. Now come to joint A again. Now we can write summation of moment about point A equal to 0 to get Cx, and that should be clockwise positive. So Cx into 6 plus 1, Cx into 6 plus 1 into 4 equal to 0. This implies Cx will be equal to minus 4 by 6 or equal to minus 2 by 3. We got Cx equal to minus 2 by 3 and we have Cx plus Ax equal to 0. So upon substituting, we will get Ax equal to 2 by 3. So same thing we are getting here. Check here, Cx equal to Ax is 2 by 3 this side and Cx equal to 2 by 3 that side. That means this minus 2 by 3 is representing towards this direction. So positive 2 by 3 will be just 180 degree. If you reverse it, that will be the positive direction. So this is the positive direction of Cx. So our values are correct actually. So after that, we need to again draw the free body diagram for joint A now to get all those K force system. Now Ax we have here 2 by 3 unit and there are two member forces, that is K AC and this is K AB, and the angle here is theta. This is theta. So we know sine theta equal to 4 by 5 and cos theta equal to 3 by 5. So again, the same thing we have to do, summation of fx equal to 0. So from here you will get KAB sine theta plus 2 by 3. Along this side I am taking positive equal to 0. So this will be KAB equal to minus 2 by 3 sine theta. So minus 2 by 3 sine theta value is 4 by 5. So when we are taking it upward, it will be 5 by 4 minus 1 by 2. So minus 10 by 12. So we are getting minus 5 by 6. So we got KAB. Similarly, when you will write summation of force along y direction equal to 0 for this joint A only, you will get KAC plus, in upward direction I am taking to be positive, KAB into cos theta. Cos theta is 3 by 5 and that is equal to 0. From here you are getting KAC as minus KAB. Minus KAB means minus of minus 5 by 6 will be 5 by 6 into 3 by 5. So 3 by 6, that is half. So we got KAC member force and KAB member force due to this unit load. Now the only member force that is left is BC. So now let us take for joint C. Now CY will be in this direction, positive 2 by 3. FAC will be in this direction. Sorry, CX was 2 by 3 and CY was 1 by 3. And this member force, that KCB, is unknown now. And this angle is theta. FAC we got as half. FS, F, this is FAC value actually, half. So now just we have to do summation of Fy equal to 0 in the vertical direction. So 1 minus half minus KCB cos theta will be equal to 0. So half minus KCB cos theta will be equal to 0. This should be equal to KCB as this will be 1 by 2 cos theta. So 1 by 2 cos theta is 3 by 5. So when it goes to top, it will be 5 by 3. So the value is 5 by 6. So now we can fill all those values. We got AB. Here our AB was minus 5 by 6 and CB was 5 by 6 and AC is half. So AB was minus 5 by 6. CB was 5 by 6. And we know the length of AC is 6 meter. And both AB and CB are 5 meters. So 5 meter, 5 meter. Now that this is axial rigidity, so here we have A as 300 mm square and E as 200 GPa for all members. So the axial rigidity is uniform throughout the truss members. So here when you will do A is 300 mm square into E is 200 GPa. So 200 into 10 power 9 Newton per meter square. So 300 mm square into 200 into 10 power 9 by 10 power 6, so that I can convert it into Newton per mm square. So overall it will become 60,000 kilonewton. As we have to keep it in the units of kilonewton so that we can divide it easily. Means from dimensional it will be homogeneous. Now this K PL by AE, that K and PL by AE, we will not divide AE. Now we will keep it as it is. We will just multiply K4 system with P4 system and L. So from here we will get, for this it will be 40 into 6, 120 by half. It will be 120. Means 40 into 6 is 240, into 1 by 2 is 120. And when you will multiply these three entity, here you will get positive 277.7, and the other one will also be same 277.7. So when you will do the summation of K into PL, you will get 675.54 kilonewton meter. Now, as we know, delta is equal to summation of K into PL by AE. So do it 675.54 kilonewton meter by AE is 60,000 kilonewton. So from here we are getting 0.0113 meter. So when we are converting it, it's coming out to be 11.3 mm. And there is no temperature variation for any of the members here also, and there is no lack of feed also. So this total column will be 0, this total column will also be 0. So our delta value, delta B in the vertical direction will be 11.3 mm. This is the final answer. So everyone got it? Or do you have any problem?
Got it, sir.
So now coming to the next question. Now see in this question, we need to take all the consideration into picture. We need to find the vertical deflection of joint B. Means this delta B vertical will be how much? Now area is given, that is same for all members. Modulus of elasticity is same for all members. Now see, the coefficient of thermal expansion is given for this question. So this is 12 into 10 power minus 6 degrees Celsius. Also, the member AC is too short. That means AC member is having some lack of fit. So for these cases, we are not calculating these values, but for that problem, this column and this column will also come into picture. So let us do that. And the temperature rise is 40 degrees Celsius. Means delta T is given as 40 degrees Celsius or member AB only. Now, so let us draw the free body diagram. Here it is hinge, so it will be AY, AX. Here it will be CY. So now let us do summation of Fx equal to 0 again. Here you will get AX equal to minus 10 kilonewton. I am doing this to be positive. So summation Fy will be equal to 0 and upward I am taking to be positive. This implies Ay plus Cy equal to 0. This is equation 2. Let us do summation of movement about point C of I equal to 0 and clockwise to be positive. So this implies Ay into 8 plus 10 into this length is also 4 meter. So the lever arm will be 4 equal to 0. So from here we are getting Ay as minus 40 by 8 or minus 5 kilonewton. So we got Ay as minus 5 kilonewton. So obviously when we will put Ay as minus 5, you will get Cy to be 5 so that the forces along vertical direction is 0 and Ax is minus 10 kilonewton. So now let us take for joint tail, let us draw the FBD. So minus 5 is upward, so 5 kilonewton is downward. Rightward Ax is minus 10, so leftward Ax will be 10 kilonewton. And here this will be FAC and this will be FAB. And this angle is 4 by 4 means this is 45 degree, this is also 45 degree. Now this is 45 degree, that is theta. Now let us do summation of Fx equal to 0 again, and this direction I am taking to be positive for Fx. So FAC minus 10 plus FAB cos 45 degree is 1 by root 2 equal to 0. Let this be equation 1. When we will do summation of Fy equal to 0 in the vertical direction, let it be positive. So FAB sin 45 degree is also 1 by root 2 minus 5 will be equal to 0. This implies FAB will be equal to 5 root 2 kilonewton. We got FAB. Now substituting FAB here, we will get FAC. So let us do that. FAC will get us 10 minus FAB means 5 root 2 into 1 by root 2. So root 2 get cancelled. So 10 minus 5 will be equal to 5 kilonewton. So FAC, sorry. So FAC we got 5 kilonewton. We got FAB as 5 root 2 kilonewton, FAC as 5 kilonewton. So this member force is done. Member force for FAB is also done. Now let us take this joint C to determine member force in member BC. We know CY, we have already got FAC that is 5 kilonewton, CY is 5. The only unknown here is FBC and that is inclined with the horizontal at an angle 45 degree. So let us do summation of Fy equal to 0 and vertical direction I am taking to be positive. So FBC cos 45 is 1 by root 2 plus 5 will be equal to 0. This implies FBC will be equal to minus 5 root 2 kilonewton. So we are done with all the member force, that P force member. So let us write it. We have member AB, BC and AC. So FAB is 5 root 2. FBC is minus 5 root 2. FAC is, where is AC? AC is 5. All are in kilonewton. Now we need to determine K force system. So here let this be AY, AX, let this be CY, and due to 1 unit vertical load, what are the member forces that will come to the K force system. Now see, this truss is symmetric about this line. So this AY and CY will be equal in magnitude. So directly we can write 0.5 and 0.5. There is no horizontal force. So AX is straight away 0. So we are done with those support reaction due to this unit load. Now let us again do the same thing for joint A. For joint A, it is like 0.5 this side. This is A, this is C, this is B. So this is KAC, this is KAB, and this is 45 degree. This is 45 degree. So now we will do summation of Fy equal to 0 in vertical direction. We are taking it to be positive. So KAB sine 45 is 1 by root 2 plus 0.5 equal to 0. So from here we are getting KAB as minus 0.5 root 2. Minus 0.5 root 2. Yeah. Similarly, when we will do summation of Fx equal to 0 for joint A only, we will get KAB cos 45 is also 1 by root 2 plus KAC equal to 0. Obviously, I have taken rightward to be positive. So here KAC will be minus KB by root 2, means minus of minus 0.5 root 2 into 1 by root 2. So it is only 0.5 units. Similarly, when we take this joint C, this is the free body diagram. FAC we know already 0.5, and this we need to determine KBC, and this is 45 degree. So we can directly write summation of Fx equal to 0, this direction to be positive. So minus 0.5 minus KBC cos 45 is root 2, 1 by root 2, sorry, will be equal to 0. So from here we are getting KBC as minus 0.5 root 2. Yeah. So minus, we can write here, we got KAB as minus 0.5 root 2 is minus 0.707. BC we got same minus 0.707, and AC we got 0.5. And we know length of AB is, this is 4 meter, this is 4 meter. So it will be 4 root 2 meter. Similarly, this will also be 4 root 2 meter. So AB is 4 root 2 meter, AC is 8 meter, and BC is also 4 root 2 meter. And now, here A is 300 mm square, E is 200 kilonewton per mm square. So 300 mm square into 200 kilonewton per mm square. So it is coming out to be 60,000 kilonewton. So, and it is same for every member. So So we are writing directly 60,000 to all the members. Now, since AE is constant for all the members, let us do multiplication for K, P and L only. These first three, K, P and L. So from here, what we will get? P is 5 root 2 into minus 0.707 into 4 root 2. So this is coming out to be minus 28.28 by AE, and this is coming out to be 28.28 by AE, and this is 2.5 into 8. This is 20 upon AE. So when you will sum this up, this minus 28 and plus 28 will be cancelled out. So you will get 20 upon AE. So substituting AE value, you will get 20 kilonewton by 60,000 kilonewton. So we are getting 20 by 60,000. This will be 3.33 into 10 power minus 2. Now, this is in meters. Now, there is temperature change also, there is lack of heat also. So, now for this case, the complete scenario won't be 0. Now, let us check the coefficient of thermal expansion, which is also alpha, denoted by alpha, is 12 into 10 power minus 6. And the member AC is too short. Too short means, suppose here the length of AC member is 8 meter. So now the AC member, when it got fabricated, the length was 8 minus 5 by 1000 meter. So here the AC member is the only member which is 5 mm too short, means lack of heat will only be applicable for member AC. So here some value will come, but these for member AB and BC, these columns will be 0 because there is no lack of heat in member AB and BC. And for this, you know the K value already for member AC, so 0.5, and it was 5 mm too short, means 5 by 1000 meter, and the complete value will be minus because it is already too short. Minus. So when you add up all these things, you will get 0.5 into minus 5 by 1000. So minus 2.5 into 10 power minus 3 meters. Now, coming to the temperature case. Now, there is a temperature rise for member A, B only. So, for other members, for AB, there will be some value, but for other members, there is no temperature rise. So, straight away for members BC and for that other member also AC, it will be 0. Now, for AB, we know already the coefficient of thermal expansion is 12 into 10 power minus 6 per degree Celsius. Length of AB is 4 root 2 meter. 4√2 meter, and delta T is 40 degree Celsius. So degree Celsius will cancel out each other. So we are getting 12 into 10 power minus 6 into 4√2 into 40 degree. So this is coming out to be 2.715 into 10 power minus 3 meter for this bracketed part only, alpha L delta D. That is the strain component for the temperature range. Now when you will multiply with the K4 system for that member only, that is minus 0.707. So minus 0.707 multiplied by this value. So answer into minus 0.707. So this is coming out to be minus 1.919 into 10 power minus 3 meter. And when you add up all these value, the same value will come minus 1.919 into 10 power minus 3. Now, the delta for joint B in vertical direction will be the summation of the external forces that will cause some displacement, the summation of the temperature cases if there is. Now in this case we do have for member AB and the summation for lack of fit, and we do have lack of fit for AC. So when you will add up, it will be minus 3.33 minus 1.919 minus 2.5 whole into 10 power minus. So what we are getting? Minus 4.077. Minus 4.077 mm. This is the final answer. So anyone who is facing any problem in this case, this was the most generalized problem what you can think of for this displacement for truss joints. So speak out if anyone is having any problem.
No problem, sir.
Okay. So shall we proceed?
Yes, sir.
Now everyone, I want to ask if everyone got the clarity how to solve all those problems of displacement for a given joint. Everyone please speak out. Yes sir, Dale, Jaiprakash.
Yes, sir. Yes, sir.
Okay. Now, see, I will give hint for this problem only and we will move forward. Determine the horizontal displacement of joint A. Now, we need to calculate the displacement for joint A in horizontal direction. So, in this direction, what is the displacement? And each member has cross-section area A equal to 300 mm square and modulus of elasticity E equal to 200 GPa. So area is given, modulus of elasticity is given. So we can directly find AE will be 300 mm square into 200 into 10 power 9 Newton per meter square. Convert it into mm square. So Newton per mm square into 10 power minus 3 will give you the whole value in kilonewton. So it will be 300 into 200 kilonewton, which is equal to 60,000 kilonewton. This is done. Now, can anyone say me from where to determine the member force? Shall we?
Some giant A, sir.
Why not from these support reactions?
Support statically indeterminate, sir. 4 reactions and 3 equilibrium equations. We cannot solve support reactions.
Yeah, that is the only reason we will start from internal joints, and we should not calculate the support reactions. So let us go to joint A now. The free body diagram for joint A will be like this. This F AB, the member force for member AB will come. Member force F AC will come. And let this angle be theta, this angle be alpha. So it is theta, and this is 30 kilonewton. This is 30 kilonewton. So when we will write summation of Fx equal to 0, we will get minus, this direction I am taking to be positive rightward, minus FAB sine theta minus 30 equal to 0. So minus FAB, and sine theta value will be, this is 4 meter and this is 5 meter. So 4 meter, 4 by 5 minus 30 equal to 0. So from here, FAB value will be, FAB into 4 by 5 will be equal to minus 30. So FAB equal to minus 30 into 5 by. So what is the value? Let me check. FAB we are getting minus 37 point. Minus 37.5 kilometer. So we got FAB value. Similarly, when we will do summation of Fy equal to 0, we will get F. So let us take upward to be positive. So minus FAC minus FAB cos theta. Cos theta is 3 by 5 equal to 0. So FAC equal to minus FAB. Minus FAB is 37.5 into 3 by 5. So it will be 22.5 kilometer. So this member force and this member force we have calculated. Now, when we will move to now let us move to joint B. So when we will move to joint B, here BD member force will come in downward direction, FBD. One member force FBC will also come, and FBA will also come. And this angle is alpha. Now, same thing, summation of Fx equal to 0 and summation of Fy equal to 0. What we will do, I am directly writing, we will get FBC equal to minus FAB cos alpha. So this value will be 30 kilonewton. Similarly, FBD will get minus 22.5 kilonewton. Now we are done with this member force and this member force also. Now let us move to joint C. When we will do the FBD for joint C, we will get 60 kilonewton is acting this side. FBC will be acting here. FCE will be acting this side, and FAC will be acting upward. And this is 60 kilonewton. Now, when you will write the equation of equilibrium, that is summation of Fx equal to 0 and summation of Fy equal to 0, we will get FBC equal to minus 60 directly, and FCE will be equal to FAC, and we got FAC value as 22.5. So FCE equal to FAC, both will be equal to 22.5 kilometers. So we are done with all the P force members. Now the step 2 will be to remove all those external force and give one unit load along horizontal direction in joint A. This is
FCD, sir. FCD first.
FCD. Yeah, sorry. FCD. FCD will come. And this angle is alpha. This is 4 meter. This is 3 meter. So this angle will be alpha. Now this angle will be alpha. So let us write the equation. FBC plus, now I am writing leftward to be positive so that minus sign won't come into picture. FCD cos alpha will be 4 by 5 and what else, plus 60 will be equal to 0, and from summation of Fy equal to 0 if you will do, and upward will be positive. So FAC minus FCE minus FCD sin alpha. Sin alpha will be 3 by 5. 3 by 5. And that should be equal to 0. So this is equation 1. This is equation 2. We already have value for FCD. Sorry, we have value for FAC. We have value for F. And from this we have value for FBC. So from here we can directly calculate FCD value. Once FCD value is done, we can substitute it here to get FCE value. So I am writing directly FCD value and FCE value. FCD and FCE. FCD value will be minus 150 and FCE value will be 142.5 kilonewton. Similarly, when you are putting one unit, that is virtual load here, we need to calculate the member force, that is K force system, again in the same manner as we are doing till now. So I am directly writing the member forces, those K force system. KAB will be minus 1.25 units, KAC, KB, KBC will be 1, KAC will be 0.75, KBD will be minus 0.75, KCD will be minus 1.25, and KCE will be 1.8. So we got the K force systems and we got the FP force system. Now the same thing we can write in tabular form, that is member, P force system, K force system, length, AE, that is axial rigidity, summation of K into PL, and we don't have any temperature, so I am not writing. Temperature and lack of heat are not there in this case. So let us write AB, AC, BC, BD, CD, and CE. So for this we got P as minus 37.5, AC as 22.5, BC as 30 kilonewton, BD as minus 22.5 kilonewton, CD as minus 150 kilonewton, and CE as 142.5 kilonewton. And we got K as minus 1.25 unit, 0.75 unit, 1.00 unit, and for BD it is minus 0.75 unit, CD is minus 1.25 unit, and CE is 1.8 unit. The length for AB is 5 meter, AC is 3 meter, BC is 4 meter, lengths are in meter, E is in kilometer, AE would be kilometer. BD is 3 meter, CD is 5 meter, and CE is 3 meter, and AE is 60,000 kilonewton. That we have calculated in the first step only. Now, when you will do the multiplication for these three entity for all the members, you will get the AB. For AB, it will be 234.37. For AC, it will be 50.625. For BC, it will be 120. For BD, will be 50.625. For CD, it will be 937.50. For CE, it will be 769.50. So, when we are summing up, we will get it to be 2162. Now, delta will be equal to summation of K into PL upon A. So, it will be 2162 by AE is 60,000. Here we have calculated. So it is coming to be 0.036 meter, it can be approximated as 36.04 millimeter. So this is delta A horizontal will be equal to 36.04 millimeter. So it is coming to be positive. So what does that signify? Means we are taking one unit is acting in leftward fashion, leftward direction. So the deflection is 36.04 mm. Means when we are taking that one unit is acting in leftward direction, the deflection is coming out to be positive. That means this joint A is deflecting towards left only. If we would have taken one to be in rightward fashion, it would have come negative. That would have signifies that the load in which direction it is acting, the displacement is occurring in the other direction or in the reverse direction. That is the significance of plus and minus in displacement. So for this case, it is plus. That means our assumptions for this unit load acting leftward is correct. So you can take this problem and you can solve as a homework assignment. So that's it for today. So any question?
Sir, previous live sessions, please share, sir.
Okay, fine. I have
And
shared you first live session YouTube link, right?
yes, sir. Second one has not shared, sir.
A second one means in that YouTube channel only I will be uploading it. So you can go to where you got the first session link.
First link.
In that YouTube channel only you will be getting the second link and the subsequent tutorial class links. So yeah.
How to access the YouTube channel, sir? You have any idea? Please tell me, sir.
Means you should not access it. Means you can get when you will write my name there, or when you are getting the link for first one, in that
Okay, sir.
channel only you will get. Means in that the means name will be same with the title name changing to be session 2.
Okay, sir.
Otherwise
Okay, sir.
I will share the link here. Please wait.
Okay.
Okay.
Okay, sir.
Please
Okay.
wait. If I will be having it now, I will be sharing it here only.
Okay, sir. Thank you, sir.
Just wait for 1-2 minutes. Let me check. Yeah, this is for session 2. I'm sharing for session 1 also. Now check. All of you got
Yes,
this.
sir. Yes, sir.
Yeah. Any more question, queries, anything? Otherwise, we will close the session.
Thank you, sir. Thank you very much, sir.
Welcome, welcome.